discuss. Now, what is it? Current to tip the ring. So let the ring tip about point P. Let me convert into some plane diagram, everything. So there's a three-dimensional what you have seen. Let me convert this into plane diagram. So it will, here is the ring. And B bar like this. This will be. Let I be the current flowing through this. So let me take point P. And it is kept on a surface. Huh? So I'm just making problem like this. So let me take this point P, which is very important for us. Now, try it on less. So what is the, how is the B bar now? Let's come for this. So what the ring will tip about point P, no? So how the dipole moment of this will be? Dipole moment M bar cross M bar will be into the plane. And how mg will act into the plane of paper. It is kept on surface. No, M bar will be in this direction. Curl fingers, right hand. So M bar cross B bar. So it will tip about the point P. So here the ring tips about point P. So then, so what is the condition for that? Torque due to dipole moment should be greater than or equal to the ring to tip about point P. To tip about point P, torque due to dipole moment should be greater than torque due to the weight. What is the torque due to dipole moment? MB, weight of the torque due to this, mgr. M naught, I'll write it, mass of the ring. It'll be easy for us. So what is M? M is I into pi r square B greater than. So already we have discussed this. I discussed this for a wire. Now I'm just bringing a ring there. So what should be the current now to tip it? Mg pi br. Keep this in hand. Okay, let's come for this. A current I that is double of the minimum current required to flip over the ring is made to circulate in the coil. Find the force of normal reaction from the table point on the ring immediately after the current is switched on. So what is our next part of the problem? If I make the current in the ring double this, definitely it will tip, no? How did it will tip? So here actually, let me bring that axis here. So this axis, what it says, how the torque due to dipole moment will be in this direction. Torque due to weight in this direction. Now when you apply current greater than this, definitely the ring will try to rotate about an axis passing through point P. If you are taking in terms of that axis, no? So this will be, what is this axis? This will be x-axis. If you are finding difficult in these things, no? So shall I say the ring will tip about in which plane the ring lies? XZ plane. So ring lies in XZ plane. Okay, now come for this one. So now the same diagram. Okay, now let me pass a current which is twice of this. Let's see that what conditions will arise here. So he's asking that normal reaction, all that one. Just is bringing some rotational mechanics ideas. Huh? These are some mixed concept. which will really help a student a lot. They're not only just magnetic force something. Application part is what I'm trying to stress here. What is the current now? So the current earlier, okay, sorry, this was I know. Now how much of current? I'm going to pass a current I. And what is this I? I is given, which is equal to 2I. So what is I is equal to? mg pi br. There's a current which will tip. Anything greater than that, it will definitely will tip. There's a current, that one, minimum current. So what is I now? 2I, it is what flowing here. Now, what do we expect here now? The normal contact will act. What are the forces that will be acting? Normal contact. Then how the torque due to dipole moment? Like this, torque due to weight. What are the conditions for the ring? So it is having now rotation motion. It is going to have angular acceleration alpha. So write it now. So what is the high Z P? Directly let me write or talk about P should be equal to torque due to dipole moment minus mg into r. What this should be equal to? Moment of inertia about an axis passing through point P. About Z axis passing through point P. This should be equal to I into pi r square B minus mgr. Torque is about P. I'm writing now torque about P. The torque due to dipole moment will try to rotate, and since the ring will come in contact only at the point P, no, so it is as good as like a body suspended. I think yesterday's class we are discussing now the same. What is the moment of inertia of this? About any tangential 3 by 2 mr square into alpha I pi r square B minus mgr. What is all the values will substitute here. What is I? I should be equal to I. Or twice of this. So directly we can write only mgr. This torque will be twice of that one. No? So if you want, you can avoid all that. The torque due to dipole moment or substitute, it's left to you. mg pi br pi r square b minus mgr. So solving this, I'll end up with alpha is equal to 2g by 3r. Keep it in hand. Anything it can be. Here, see, okay, the torque due to dipole moment will try to swing the rod. If you set free to rotate, it will rotate about axis passing through center of mass. And what about here? You are forcing it to rotate about point P. And anyway, the torque passing through center of mass will be parallel to that. So the magnitude of torque will be same. Sometimes you would have to take component of that. I think these are some problems, application problems. What are there in rotation mechanics? I think there's a basic idea of the torque, no? Skew symmetric vector. I think in SU Verma, one definition he has put it. Okay, now after this, what is our question is normal reaction, no? How to get that normal reaction? I think, okay, I'll keep this much of diagram in it. How to get the normal reaction. Look at the state of the ring. I'll include everything here only. So what are the forces that will be acting on the ring? So let's go for the forces acting on the ring. So this is the point P. Normal contact. Here the weight. Okay, this is a ring. Then there's a weight and there'll be torque due to dipole moment. Torque due to dipole moment. So then definitely what will happen? It will try to have acceleration. and it is having here alpha. So what is the equations of motion? You can write n minus mg equal to me. And what is A? A is equal to r alpha. So n minus mg equal to m r alpha. And value of alpha we know. Substituting this mg plus mr alpha. Alpha is 2g by 3r. So normal reaction will become equal to 5 mg by 3. And what is mg further? So mg is not given for us. No, mg you can replace from this data. Pi br. This will be our end answer. At that instant, we are finding out. At that instant, the ring will try to tip. Then n minus mg should be good. This one. See, like what actually happens here? The rod will tip. No, I think you have to understand. Just I'll trying to show in the video what actually happens here. It is like this. No, it will tip. No, since we applied a current more than the minimum current to pass, no, it will tip here. So it will tip about select this like this point. So therefore, the moment it starts tipping, so it will first will happen there. So what will make it to that one? So the acceleration of center of mass, n minus mg equal to ma, the translated motion. It will not. It is kept like this here. It will tip. It has to tip, no, totally. So what? Look at the center of mass now. Earlier it is here. After some time will come here. So the center of mass is going to undergo displacement, no. So there we are writing translated motion here. Take next one.
Second one, scroll down. Thank you, sir.
Come for this.